Section 1-6, midpoint and distance in the coordinate plane. The objective of this lesson will be to develop and apply the formula for midpoint and use the distance formula in the Pythagorean theorem to find the distance between 2 points. Let's begin with midpoint formula. If you remember from the previous segments, midpoint is the point in the middle of a segment. So on this picture they have here, M is the midpoint of AB. Now the midpoint formula says the midpoint M of segment AB with endpoints A at x1, y1 and B at x2, y2 is found by this formula right here. Now the reason they have these small ones right here next to the x and y is because this is the first point they've given you. This one has the small 2's because this is the second point they give you. That way you know which ones to use where. Let's go ahead and try an example so you can see how we work this. For this one, it's asking you find the coordinate of the midpoint of CD, segment CD, with the endpoints C at -4, 2, and D at 8, 7. So I would begin by labeling your points. This is my first point, so this is going to have x1, y1. This is the second point, so this one will be our x2, y2. Now the only thing left that we have to do is to plug it into our midpoint formula. First it says take x1, that's -4, plus x2, which is 8. We're going to take that and divide it by 2. We're going to put our comma. Your answer is going to be a coordinate point, so don't forget your comma. y1 is 2, plus y2 is 7. And then divide that by 2. So -4 plus 8 gives you +4. And we're going to divide by 2. 2 plus 7 is 9 over 2. Okay, and we can simplify this even further. 4 divided by 2 gives me 2. And 9 divided by 2 is 4.5. So the midpoint of segment CD is 2, 4.5. Next is the distance formula. In a coordinate plane, the distance D between 2 points, x1, y1 and x2, y2 is this formula right here. So the distance formula will calculate how far one point is from another. We're going to go ahead and start on example 2. It says find the length of the given segments and determine if they are congruent. So first here we're going to find the length of RS, and once we have that we're going to compare it to FG and see if they are the same distance. Okay, so first I need to know what the coordinates are for these points. We have R right here, and he is at -3, -2. And S is at -3, -5. Or sorry, that should be +3. Okay, now you can choose who you want to be the first point and the second point, so you can determine who gets the subscript of 1 and the subscript of 2. So I'm going to have this guy be x1, y1, and this is going to be x2, y2. And then we're just going to plug it in. So first, the square root of x2 minus x1 squared. So x2 is 3 minus x1 is -3. We're going to square that. Plus y2 minus y1 squared. y2 is -5 minus y1 is -2. Okay, now if you look here, a minus and a negative, remember that they will always cancel and they will become positive. So this right here is now gone. Here we have a plus. Same thing over here, we've got two negatives, a minus and a negative, they will cancel. So now they've turned into a plus. So let's go ahead and simplify here. Now we have 3 plus 3 which is 9. We're going to square that. And here we have negative 5 plus 2, which is negative 3, and squared. Okay, let's keep going. 9 squared is 81, plus negative 3 squared is 9. Now 81 plus 9 gives you 90. So the distance of RS is equal to the square root of 90. Now let's find the distance of FG. So this one right here was RS. Now we got to find FG. Let's separate this here. So F is right here. That's at coordinate point 5, 4. And G is at 3, negative 1. Let's go ahead and label. I'm going to make this one my first point and this one my second point. And now we can plug it into our distance formula. So distance equals the square root of x2 minus x1. x2 is 3 minus x1 is 5. We'll square that, plus y2, which is negative 1, minus y1 is 4 squared. Okay, let's go ahead and simplify what's in our parentheses. 3 minus 5 is negative 2 squared, plus negative 1 minus 4 is negative 5, and we will square that. Okay, now negative 2 squared is positive 4. Negative 5 squared is 25. 4 plus 25 is 29. So the distance from F to G is the square root of 29. And if we look, these two distances are not congruent. So we can say that the lengths of these segments are not congruent. The last equation is the Pythagoras Theorem, which says in a right triangle, the sum of the squares of the lengths of the legs, so these are the legs, is equal to the square of the length of the hypotenuse, which is right here. And we write that as a squared plus b squared equals c squared. And don't forget the hypotenuse is always opposite the 90-degree angle, and it will also be the longest side of your right triangle. So let's go ahead and do example 3 so we see how we use this. Here it says to use the distance formula first. We are not going to do this part since we just did the distance formula. So we are only going to use Pythagorean theorem to find the distance to the nearest tenth from 3, 4 to e, negative 2, negative 5. So let's go ahead and plot these. Point D is at 3, 4. And we have E at negative 2, negative 5. We're going to go ahead and connect this. Okay, now you're probably thinking, there is no triangle. How am I going to do this? Well, you can create a triangle with the points you have right now. Just bring this one down and this one over, and we've got a right triangle. Now we're going to use our coordinate plane here to help us find the lengths of each side. The length of the space is 1, 2, 3, 4, 5. So this is 5. And the height of our triangle, 4, 5, 6, is 9. Okay, so we're going to use 5 and 9. So our equation is a squared plus b squared equals c squared. And this is the side we want to find. We don't know what c is. We can't count like we did with the 5 and the 9. Now for a and b, it does not matter which leg you choose for a and b. It is your preference. For this example, I'm going to choose the 5 for A and the 9 for B. So let's plug it in. A is 5, so we're going to take that and square it. B is 9, square that. And then C, we don't know. So 5 squared is 25, plus 9 squared is 81, equals C squared. 25 plus 81 is 106. Now this is C squared. If you remember, to cancel a square, we take the square root of both sides. So C is equal to the square root of 106. And we're just going to leave it like that instead of finding the decimal.